In this video, we're going to go over linear functions and how to graph them. And this is section 1.3 of our textbook. So we'll start with this here. So a function f defined by f of x is equal to ax plus b, where a and b are going to be real numbers, is called a linear function. And its graph is called a line. And its solution is going to be an ordered pair that will make our equation true. So we'll start with an example. We are given the function here, 3x plus 2, and we can see already that this is a linear function. It is of this form here, or in this case, our a is 3 and our b is 2. Now the first thing we want to do is find our x and y intercepts. And so first, to find our x-intercept, and I'm going to abbreviate it like this, we're going to set y is equal to 0. And actually, before we do that, just to give us a visual interpretation of the x and y intercepts and why we are setting y equal to 0 here, is, say this is our y-axis here, and this is our x-axis. If we have a line that looks something like this, then this point here is called the y-intercept. It is where our graph here intercepts the y-axis. And then this point here is called our x-intercept. It is exactly where our graph intercepts our x-axis. And so in order to find our x-intercept here, notice that our y value for our x-intercept is 0, and then our x value for our y-intercept is 0. So to find our x-intercept, we want to see for what values of x will we get that y is equal to 0. So what x value is this, pretty much. And then this is just a random example. This is not the graph of this function here. Okay, so we're going to set y equal to 0. Remember, y is our f of x. So 0 is equal to 3x plus 2. And we want to solve for x. So we're going to take away 2 on both sides. We get negative 2. Sorry, I am getting ahead of myself. We get negative 2 here, and that'll be equal to 3x. And then to isolate x completely, we're going to divide by 3 on both sides. So we get negative 2/3 is equal to x. And so this means when x is equal to negative 2/3, our y value is going to be 0, and that is our x-intercept. This is also called our 0 or root of our function. Okay, now similarly, we want to find our y-intercept. Remember, our y-intercept is here, and our x value for our y-intercept is 0. And so we want to figure out what this y value is here. So we'll set x equal to 0. Now we have our function f of x is equal to 3x plus 2, so we're just going to plug in 0 for our x here. So we're plugging 0 into our function of x. So we get 3 times 0 plus 2. And so we get that our y value is equal to 2. So this tells us that our y-intercept is equal to 2. So at this point, or at our point 0, our y value is going to be 2. The next thing we want to do is find the 0 of our function. Now these will be x values that make our function 0. And if you remember from up here, we found exactly that for our x-intercept. we know that this x value here will make our function equal to 0. And so that's why I mentioned this here. This is also known as the 0 or root of our function. So if you were asked to find the zeros of your function, you would set your function equal to 0 and solve for x, and you do the same if you were asked to find the roots of your function. All right, so now what we can do is we can graph this. We can have a rough sketch because we have 2 points. Our x-intercept tells us that we have 1 point, -2/3, 0, because our x value is this and our y value is 0. And then our y-intercept tells us we have the point 0, 2. So at the x value, x is equal to 0, our y value is 2. And we can plot these points. So again, our y-intercept, we have 0, 2, so let's say 2 is right there. And then our x-intercept, we have a -2/3, 3, so let's say that is -2/3. So our graph would look something like this. And for homeworks and stuff, you should use a graphing calculator or a graphing program. Just to check your work. And so yeah, just to check, you should still be able to graph these using this process we just did. And a good program that you can use is Desmos to check your work. All right. So this particular function here, f of x is equal to b, where b is some real number, is called a constant function. So an example of this would be f of x is equal to 3. And what this looks like, if we were to graph this, we're told that our y value is just equal to 3. So we just have a constant function here. No matter what, we will just get 3. And so this is what our graph looks like. Y is always equal to 3, so we just have a horizontal line in this case. And here, notice that the slope of our line is 0. Similarly, if we had x is equal to some constant, x is equal to 2, in this case, we just have that x is equal to 2 no matter what. So our graph would look, try to keep it straight, our graph would look like this. And so in this case, we have a vertical line. And in this case, our slope is undefined. And I'll go over that a little more in a second, but this brings us to our slope here. So the slope denoted lowercase m of the line passing through 2 points here is going to be the change in our y values, so that's what this triangle means, over the change in our x values. And in order to find the change in our y values, we will subtract them, and similarly for our x values. Now something to note here is that our change in our x values cannot be equal to 0, because of course we can never divide by 0. In that case, our slope would be undefined. So let's look at an example of this. Let's say we're given these 2 points. In this case, 4 is our x1 and 5 is our y1. 3 is our x2 and 6 is our y2. So all we have to do is plug this information into our formula here for our slope. So our slope m is going to be equal to y2 minus y1. So we got 6 minus 5. over x2 minus x1, so 3 minus 4. All right, so then we get 1 on the top, negative 1 on the bottom, and this tells us our slope is negative 1. Now notice, if we were to have a vertical line, like how we saw up here, so let's say we had a vertical line at x is equal to 1. One point on this line would be 1, 1, and that would be there. And then another point on this line would be 1, 2, and that would be roughly right there. So if we had 1, 1 and 1, 2, and we wanted to find the slope of the line passing through these 2 points, we can just use our formula that we just saw. So doing y2 minus y1, we have 2 minus 1 on the top, and then x2 minus x1, we have 1 minus 1 on the bottom. In this case, we have 1 over 0. And remember, we can never divide by 0. So this is undefined, and we can abbreviate that UND. And so that's why whenever we have a vertical line, our slope is undefined. All right, so the last thing we're going to look at is this word problem here. So suppose we're told that a library that is closing currently has 120 books on its shelves, and it's donating their books at a rate of 3 books per day. We want to write a linear equation to represent this information, and then determine how many books will be left after 5 days. So we want to write a linear equation that will represent how many books are left after a certain amount of days, so after x days. So our variable x is going to be equal to days, and we're going to write a linear equation dependent on the number of days. So f of x is going to be our linear equation that represents how many books are left on the shelves after a certain amount of days. So we start with 120 days, and we know that we are taking away these books, we're donating them. So we'll have a minus here, and we're donating 3 books every x days. So this will be our linear equation. And notice here that our 3, our minus 3, is our constant rate of change. So every single day, the amount of books that we have is changing at this constant rate of minus 3. All right. The next thing we want to do is determine how many books will be left after 5 days. So what we can do is plug in 5 for x. So we have f of 5 here. Plugging this into our equation, we have 120 minus 3 times 5, so minus 115. And so we get that after 5 days, we will have 105 books left on the shelves. All right, and then something else to note here is that in standard form, we'll write the 3x before the 120 here. Okay, and then with that being said, we'll use the fact that we have an equation in slope-intercept form to graph it. So let's go down here. So we have our equation, f of x is equal to minus 3x plus 120. And we know that this minus 3x here is the slope. We have a negative slope. And this value 120 here is our y-intercept. And if you remember from earlier in this video, to find the y-intercept, what we do is we set x is equal to 0. And so if we do that in this form, then the slope goes away, this term goes away here, and we're just left with 120. So that's why we know that this is automatically our y-intercept, and that's why this is called slope-intercept form. And then if you remember from college algebra, our slope is going to be a rise over a run, and so we'll use that to graph this equation. So we'll use that and the fact that our y-intercept is 120, so we'll say that 120 is right about here. So we know that our graph is going to intersect the y-axis at that point. And then we also know that our slope is minus 3. So our graph is going to be going in this direction because we have a negative slope. And we know that rise over run, so our rise will be 3 and our run will be 1. So that means we're going to go over 1 and then down 3. Then we'll go over 1 and then down 3. And this is just a rough sketch. It should be something like this. Over 1 and down 3. And so our graph is going to look something like this. And then we can also find the exact value for our x-intercept by setting this equal to 0 and then solving for x. Alright, so that will be it for this video.